Hello everyone. So in this video we're going to talk about how do we use probability rules to find probabilities of events, and how do we find sample space. So before you watch this video, please make sure that you read the corresponding part in the canvas. So basically there are a few concepts: sample space, events, probability, and also the 5 probability rules. So you need to understand. Okay, so let's look at the question here. So in the first question, we have a bag. A bag has 10 balls, and out of the 10 balls, we have 5 green balls, 2 blue balls, and 3 red balls. Okay, it's a pretty simple scenario. So we have total 10 balls, 5 green, 2 blue, and 3 red. So if we randomly take one ball from the bag and record the color of the ball, what is the sample space? So if you understand the sample space definition, it's pretty straightforward for the question. The sample space is all the possible outcomes. All the possible outcomes. Okay? So then we are recording the color of the ball we randomly take from the bag. So basically the question is asking, what are all the possible colors that you could observe out of the ball that you take from the bag? So since we know there are only 3 different colors, green, blue, and red. So if you take a ball from the bag, then you could either observe a green or blue or red. So that would be your sample space. That's all the possible colors you can observe. Okay. So the next question is, what's the probability of each of the outcome in the sample space? So then in the sample space we have 3 different outcomes, right? So what's the probability of each of the outcome here? So basically, what's the probability we observe a green color ball if you randomly take a ball from the bag? That's pretty straightforward. We have 5 green balls. Out of total 10 balls, will be 5 out of 10, right? And probability of blue will be number of blue balls, 2 out of 10. And probability of red will be number of red balls, 3 out of 10, right? If you add up together, the total will be equal to 1. Okay? So that's our second probability rule. The probability of any sample space need to be equal to 1. So it need to be true for any sample space you define. Okay, so that's question number 1. It's pretty straightforward. Okay. So now we're going to make things a little bit more complicated. So instead of looking 1 bag of balls, we're going to look at 2 bags of balls. So in each bag, we're still going to have 5 green, 2 blue, and 3 red. But we have 2 bags. Okay. So now we are going to randomly select 1 ball from each bag. So we have ball 1 from bag 1. We have ball 2 from bag 2. And we're going to record the color of each ball. So we have 2 balls. We need to record the color of each of them. And what's the sample space? Okay. So the outcome will be have 2 colors, right? So different color combinations. And then we need to find all of the different color combinations. That will be our sample space. So the space is pretty small here. We're going to use a blank page. So remember the scenarios. When you have 1 bag, so for ball number 1, we know we could have either green or blue or red, and that's our sample space, right? So after we add another bag, we add another ball basically, we can make this more complicated. So we have another color we need to record. That's the second ball color, ball 2. So the process is pretty straightforward if you understand if you just do it systematically. So basically we're going to fix the first first ball color. We're going to fix it as a green first. Okay. Then if the first ball is green, is being fixed, what kind of color can it be for the second ball? It could be also be green or blue or red, right? Then if the first ball color is fixed as blue, the second ball color could be green, blue, or red, right? And if the first ball color is fixed as red, the second ball color could be green, blue, or red. So basically then we listed all the possible color combinations of two balls we take from both bags. And that's going to be our sample space. Okay. And the next question will be find the probability of each of the outcomes from the sample space. So basically we have 9 different outcomes. Then we need to find the probability of each of the outcome in the sample space. So let's start from find one of the outcome. And the process will be the same for finding any other outcome probabilities. So for example, we find the probability of the first outcome, green, green. Basically the event only have one outcome from the sample space, right? So if you write this out in Word, basically it will be probability of the first ball you draw, ball 1 is green, and the same time the ball 2 also need to be green, right? So then we can see the event become a complicated event connected by and between two simple events, right? So probability of A and B. And A is ball 1 is red, B is ball 2 is red. So for probability of A and B, if you look at probability rules, we can use multiplication rule. It will equal to PA times PB. And we need to check the condition A and B are independent. You can only use that multiplication rule when A and B are independent. Independent just means they don't affect each other. So whatever happened to A doesn't affect B. Whatever happened to B doesn't affect A. That's independent. So now let's look at if A and B are independent or not. So A is ball 1 is red, B is ball 2 is red. So basically the question will be, is ball 1 being red or not affect ball 2 being red or not? So since there are two different bags and they randomly select one ball from each of the bag, so it doesn't affect each other, right? So whether the first ball is green or red or blue doesn't affect the probability of the second ball is green, red, or blue, right? So they're independent. Since they're independent, we can apply multiplication rule. So that will be probability of event A, ball 1 is green, times probability of ball 2 is green. So the complicated event become a product of two simple events. So then we look at ball 1 is red. What's the probability ball 1 is red? So basically only look at the first bag, right? So the first ball being green, probably the first ball 1 is green. I keep saying red. So probably the ball 1 is green will be 5/10, which we find from the first question, right? 5/10. Then we just write 5/10 times, and then probably the ball 2 is green. Basically the ball 2 probability ball 2 being green has the same probability as ball 1 being green because they are the same bag, right? The probability of ball 2 being green is also 5/10. So if we do the math, it will be 25 out of 100. So 25%. Okay. So then we got green has probability of 25%. And then for the same process, we can do probability of all the other outcomes. So green and blue, basically ball 1 is green and the ball 2 is blue. Since they're independent, they don't affect each other, we can use multiplication rule, become probability ball 1 is green times probability ball 2 is blue. And then ball 1 green is 5/10, ball 2 being green, ball 2 being blue will be 2/10, right? So then 5/10 plus 2/10, we're going to get 10/100. That's 10%, right? So I'm going to write it here. Green, 5/10, blue, 2/10, and red, that's 3/10. Basically, these are the probability defined from step 1. Okay. Then similarly, probability of green, red will be probability of green times probability of red. You know, the same process, right? So that will be 15%, 15/100. And the blue, green will be probability blue times probability green. That will be 10%. And blue, blue will be blue 2/10 times 2/10. That will be 4%. And then blue and red will be 2%, 2/10 times 3/10. That will be 6%, 6/100. And the red and green, probably red times probably green, will be 15%. And red and blue, probability of red times probability of blue will be 6%. And then probability of red and red will be 3/10 times 3/10 will be 9%. So then we got all the probabilities for different outcomes. Okay. So if you want to verify, the probability have to add up to 1 as well. So anytime you have a sample space, the total probability of the entire sample space is always equal to 1. That's the probability rule. Okay. So then question number 2 is done. Now we're going to look at question number 3. So question number 3 is based on the events we have in 2. So we're still gonna take one ball from each of the bag. And now we're not looking at the color of each of the balls. So instead, we're gonna define a variable differently. We're gonna define a variable x as number of red balls out of the 2 balls we take. So basically, we're going to randomly select a ball from bag 1, randomly select a ball from bag 2. So we're going to have 2 balls to look at. And then the variable we're defining is number of red balls. So what's the sample space? The question will become, what are all the number possible of red balls when you look at 2 balls, right? Basically, how many balls are possibly being red. Okay, so it's pretty straightforward if you understand what the question is asking. You have 2 balls to look at. If neither of them is red, then the number of red balls will equal to 0, right? Then if both balls are red, then the number of red balls will be equal to 2, right? And then of course, if one of them is red and the other is not, then you have number of red ball equal to 1. So the sample space will be 0, 1, or 2. That's our sample space. So now we need to find the probability of each of the outcome from the sample space. So we need to find what's probability of x equal to 0, what's probability of x equal to 1, what's probability of x equal to 2. Okay. So now we need to go back to the sample space we defined earlier for the color combinations of 2 balls. Okay, so we're going to look at all the combinations. So probability of x equal to 0, that means neither of the 2 balls is red, right? So that means it could be green, 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 right? And because there's no red ball in there. And green, blue is also possible, right? Number of red ball equal to 0. Or blue and green, right? Blue and green. And blue and blue. So blue and red, green and red has red balls. Red, green, red, blue, red, red. The rest outcomes all have red balls in it. So these are all the possible events that outcomes that could have different, could have, 0 red balls. Okay. So probability x equal to 0 will be either green, green, or green, blue, or blue, green, or blue, blue, right? So there are events connected by or. So from probability rule, probability A or B equal to PA plus PB. So then we need to check if A and B are disjoint. Disjoint just means they don't have any common outcomes. Since all the events here are individual outcomes, of course they don't share any common outcomes, so they are disjoint. Then we can use a descent rule. So that will be probability of green, green plus probability of green, red, green, blue plus probability of blue, green plus probability of blue, blue. So then if we look at the probability of each of the outcomes we find here, we can just add them up, right? So green, green will be 25%, and green, blue will be 10%, and blue and green will be also 10%, and then blue, blue will be 4%. So we add them together will be 25 plus 10, 35 plus 10, 45 plus 4, that'll be 49%. Okay, so that's probability of x equal to 0. Then probability of x equal to 1 will be, basically we look at the combinations that has one red ball, right? So it's red and other colors. So then we could have green and red, or blue and red, right? Or red and green, or red and blue, right? So we need, basically, again, we can use a descent rule since they're all disjoint to each other. So then green and red probability is 15%. Blue and red will be 6%. And then red and green 15%. And then red and blue will be 6%. So we add up together 15, 6, that's 21, and they have another 21, so it's 42%. Okay, and then that's probability x equal to 1. Then probability of x equal to 2 will be basically which combination of the colors will give you both balls being red, right? So basically there's only this one single outcome, red, red, right? So this equal to probability of red, red. There will be 9 out of 100. So probability x equal to 0, 49%. Probability x equal to 1, 42%. Probability x equal to 2 will be 9%. And of course, if you add the probabilities up for the entire sample space, it's always equal to 1. Okay. So this is how I use probability rules to find some probability in some simple probability models. Thank you for watching. Bye-bye.